Okay. Sorry, have you all written down the heading? Okay, I'm moving up so that you can maybe see the picture as well. Here we go. That's the picture. Okay. You've done something very similar to this. Oh. Okay.
You right?
So those two triangles would be similar.
Yeah. I don't know.
Okay, guys. Have we This picture might be familiar. It's rectangular midpoint theorem. You don't need to remember exactly what it says, but do you remember that that was a thing? We had parallel lines, midpoints, blah, blah, blah. So the midpoint theorem is actually a specific case of prop theorem. Okay, so it's called proportional division theorem. We just call it prop theorem, and that's also what the reason is. I'll write it down for you just now. So you can just draw that picture, guys. I'm going to write some stuff next to it. Also, we do have to prove this theorem, but we're first going to practice it and then prove it. Okay, you guys know that I like doing that later on. They actually asked this proof in the sub exams, so they probably won't ask it in supplementary exams, the June exams, with this theorem as they are. So was it a similarity? I'll have to check actually for one with you. No, the departmental. The rewrite. Okay, so what does prop theorem say? A line drawn parallel to one side of the triangle. So we're looking at the triangle being triangle ABC, yeah, right?
Yeah.
Then DE is drawn parallel to side BC. So then they're saying that line will divide the other two sides in the same proportion. So the other two sides, oh my God, what is going on with this? So the other two sides that they are referring to here are AB and AC. I'm just going to say that again. A line drawn parallel to one side of the triangle. So this is the line. The line that they're referring to all the time. It's drawn parallel to side BC. It will divide the other two sides of the triangle in the same proportion. Sometimes they say proportionally instead of in the same. It means the same thing. Okay, so I'm just going to write down here. We can make a whole bunch of conclusions about this triangle, this theorem. Okay. Basically, what we can say is that AD, so that section, over BD or DB, right? That bigger section over the smaller part is equal to, it's divided in the same proportion, will be equal to AE, again, the bigger part of the other side, over the smaller part of that same side. See. We are going to practice using it now, so then we'll see exactly how we can use this. The reason is going to be prop theorem. And then you always have to state two parallel lines. So this is like all the angles, the corresponding angles are on. The reason for us having to state that these lines are parallel is because that's what the theorem says, right? This theorem only works if you have a parallel line that's parallel to a side of the triangle. Okay, so you have to say DE parallel to BC. You just write prop theorem, no more. Okay, we can talk about other ratios here as well. We can say maybe this top part over the whole side is equal to that top part over the whole side. That's also true, right? So we can also say AD over AB. So top part over whole side is equal to top part over whole side. Okay, AE over AC, and then your reason will be the same. I'm going to write one more option. There actually are a few more. We can also start with the smaller part, right? So we can say BD over AB, right? So if I'm taking the small part over the whole side, on the other side, I'm also going to have to take the small part over the whole side. Okay, so I can write BD over AB. What's the name of the small section on the other side of that triangle? EC or CE. Over, we use the whole side, so the whole side here is AC. And again, you would write the same reason. And I'm just going to write etc. Okay, you could actually carry on. You could also do small side over bigger part equals small side over bigger part. Big part over top part, big part over top part. Okay, you can actually. So guys, this is one way of writing ratios. What is a different way of writing ratios? Instead of writing it as a fraction, yeah. Yes, I'm not thinking about that yet. We will get to that yet, but yeah, that is true. What is it? With the semicolon, right? So let's just maybe add, yeah, let's work with decoration. So you can also write it like this, guys. Okay, instead of writing it as a fraction, you can write it as a ratio like that. We just usually work with fractions more often than with ratios, but they are interchangeable. Examples with ratios. Yeah. Okay, now guys, it might not really make sense of what's happening here now. We're going to do an example now with numbers, and I think it will make it right on here. Are you done copying this down? Okay, so example 1, you can just copy that down, please, and then we're going to do this example together. Okay, so they've given that picture and they're asking us to find the length of a. Okay, guys, I can already see some of you trying to figure this out on your own. There are multiple ways in which you could do the actual calculation. So let's just quickly see what are they asking us for here? For AC, which is this whole side, right? Now you might think, okay, let's find A each, but then I can just add it to 3 and then I have AC. That's fine. If you want to do it that way, no problem. I will write that solution down. A faster solution, though, would be to think, if I can, and let's also recognize that we can use prop theorem here, right? Because DE is a line that is parallel to a side of this triangle, which is BC. So that means that DE divides these two sides in the same proportion. So AD over BD will be equal to AE over EC, for example. You can use that, right, to calculate it. But like we said for this last option that we wrote over here, we can basically take whichever side we're trying to find and put that at the top of our first fraction. That will make the whole solution a bit easier. So what side are we trying to find? AC. Do I have, which is the whole side, right? Do I have the whole side on this side? Yes, 6. Okay. Then do I have another pair of like parts of sides that's the same, or the same proportion? I have the bottom part and the bottom part there. Okay, so I can say, take the whole side AC over the bottom part CE. Now, because I have this parallel line, the ratio is going to be the same on the other side of the triangle. So again, the whole side, which is AB on that side, over the bottom part, BD. Reason, prop theorem. Try to find parallel lines and I don't know about space. Good. Okay, yeah. Notice that the side that I'm trying to find, I put at the top of my first fraction. Okay. Thank you. I'm just going to fill in those values. AC over, what's the length of CE? 3 equals, what's the length of AB? 6 over the length of BD is 2. So what is AC going to be equal to? What does I do with that 3? Times it out, okay? What's 6 divided by 2 firstly? 3 times 3 is 9. Now guys, yes, you could have done this by inspection. Okay, you could have, if you looked at the ratio here, maybe you said, okay, this is 6 to 2, right, which is 3. So this must also be, this big side must also be 3 times the small side. I'll just say that again. Sorry, my wording wasn't great there. You could look at the length of the whole side is 6, and the length of the small part is 2. So the whole side is 3 times the small part, right? 2 is 3, 6 is 3 times 2. So you could have done the same thing here. This whole side needs to be 3 times the bottom part. Okay, but you can also just do a calculation. Let me quickly write down if you wanted to calculate AE on its own and then just add that to 3, that also would have been fine. Right, if you wanted to do AE over CE, what's the other side going to be? Top over bottom, right? AD over BD. Okay. Again, same reason. Then you can fill in all of those values. AE is the one we are trying to find. CE was 3. That is equal to AD was 4. And BD was 2. 4 over 2 is just 2, hey? And then you must times that by 3. So from that, we will get that AE is 6 units. But they were actually asking for AC, which is AE plus E. All right, 6. This is 6. 6 plus 3. 4 AC. Okay, any questions? As it is going to take a while for you to get used to this, we haven't really worked with ratios since grade 9, actually. It comes up every now and then in a question some way, but yeah, that's just give yourself some time to get used to working with these ratios. Okay, we're going to do another one quickly, which is a bit more complicated. So example 2 is that. And the ratio is given here on the side, thank you. All right, guys, we have about 8 minutes, so we need to get going. All right, they've given us a ratio there, guys. Let's just look at this ratio. They're saying that AL to LB. So this section that we're now going to find. Never mind. To the smaller part, LB is in the ratio 5 to 3. Does that mean that this is 5 millimeters and 3 millimeters? No, just the ratio, right? It can't be 5 and 3 because this is 24 millimeters. Okay. So guys, if you want to, you can actually fill that in on your diagram, but you cannot just write 5 and 3. Because if you just put a 5 here and a 3, it's going to look like you're saying that this is 5 millimeters and this is 3 millimeters. So what you can do is you can put them in terms of a variable. Okay, to show the ratio actually on your picture, you can do that. So 5x and 3x. So guys, if this side is divided in the ratio 5 to 3, how many parts is this side in total? 8 parts, right? 5 parts and 3 parts, so 8 parts. So what I'm going to do is, I'm going to say that the 8 parts would be equal to 24. I'll show you now a different way of writing it, which some of you might feel more comfortable with. This is perfectly fine. 24 divided by 8. 3. Times 5. So AL is then 5x, 5 times 3. Guys. Which is 15 millimeters. And you can then fill that in on your picture. I think in lower grades, I'm actually not sure if you even did question like grade 8, maybe, grade 9, maybe. You could have said, okay, this is 5 parts, that's 3 parts, so 8 parts altogether. So 1 part will be 24 divided by 8, right? Which is 3, which is basically what I did here. I just used an X to represent the parts, okay? So then, if AL is 5 parts, then you're going to do the exact same thing. 5 times 1 part will give you 15. Okay, can we figure out what this one is, guys? I'll be 9. Okay, so you can fill that in as well. 3x, 3 times 3. No, 9. 9. I'm just doing my grass. Okay, quickly. B, let's go. Last one. We have 2 minutes. Quickly. Determine the length of CM. Determine the length of CM. CM is this one. Guys, you're making it hard for me today. Hey, wow. I'm earning my salary. CM, that's the one they're trying to find now. What can I use? Crop theorem. CM over 20 is equal to 9 over 15. This CM over 20 is equal to 9 over 15. Okay. CM over 20 is equal to 9 over 15. Crop theorem. BC parallel to ML. You're just going to have to take my word for it. So those are lines that are parallel. So now 9 over 15 goes off. You can simplify that. That's actually 3 over 5. Doesn't matter. You're just going to take whatever that is and you're going to multiply it by 2. Okay. So that will get you to an answer of 12 millimeters. Okay, I am on the way out. You're going to collect a worksheet from me and you're just going to do the first 2. The There's two. Oh, guys, also please put the chairs on the table. I'm gonna try what I need to do. Okay, and then
What I was saying is,